Okay, hi everybody. This is my friendly reminder that I don't think you should just copy everything I do off of this video. I hope that you'll try the problems before you start. Should help a little bit in terms of your ability to do the problems independently. So do that. So with that said, I'm gonna try to walk through these problems so that you can see how I do them. Not every problem is I'm gonna do exactly the same way as you, and that's fine. Just try to make sure your answers are making sense and making sure they're the same as mine, and also like make sure that what I do also makes sense in your brain. So here we go. Um, the first problem is we're supposed to solve all these triangles. We're supposed to find all the missing angles, measures, and all the side lengths. And so the first thing that I see is that I have an angle called 41 degrees. I'm going to label my triangle opposite, adjacent, and hypotenuse, which will help me see that I can use cosine or sine to find one of the missing sides. I'm going to call this y, and I'm going to call this x. So um, cosine of 41 is equal to x over 12. Just make sure that you're in degrees in your calculator while you're doing this, because otherwise it's not going to work. Multiply both sides by 12. I get x equals the 12 times cosine of 41. And so that gives me about 9.06. I want to make it a routine to round to two decimal places on this worksheet. So 9.06. Now we can use sine to solve for y, or we can do Pythagorean theorem. So I'm going to write 12 squared equals x squared plus y squared. I want to remind you to please just round one time. So you want to keep that 9.06 decimal in your calculator and then square it in the calculator with the whole long decimal, even though you wrote a shorter decimal. So just be careful about that. So 144 minus that number is 61. So that means that y equals y squared equals 144 minus 82.02, which is, so that y squared is 61.97. Take the square root of that answer and we get y equals 7.87. Okay. So y equals 7.87. The last thing I need to do is to get that last angle, and that's this angle. Remember that the three angles add up to 180, so I can do 180 minus 41 minus 90, which is 49, and so this is a 49-degree angle. Okay, so the reason that this problem is different is because we have two side lengths this time instead of angle and a side length. So we're going to need to use an inverse to solve for an angle. So I'm going to say this is my angle. And so I would say let's call this theta. So theta equals the cosine inverse of 9 over 17. And so let's see, cosine inverse of 9 over 17 is 58.03. So theta equals 58.03 degrees. Again, make sure your calculator's in degrees. If that's true, then we can figure out that this angle is whatever 180 minus 90 minus that is. And so that gives me 31.97 degrees. Okay, now the last thing we need to do is find that last side length. And so we're going to use Pythagorean theorem to do that. So we'll say 17 squared equals 9 squared plus, and I'm going to call this x squared. So solve, we get 17 squared is 289 minus 81 is 208. So then I say minus 81 minus 81. I get 208 equals x squared. Take the square root, I get x is about the square root of 208, which is 14.42. Okay, great. Number three is really similar to the last one, except what we don't know is the hypotenuse, because this is the hypotenuse, this is the adjacent side, and then this is the opposite side. I'm going to use sine. So I'm going to say sine of 57 is equal to, and I'm going to call this x and this y. Sine of 57 is equal to 10.8 over y. We can multiply both sides by y and then divide both sides by 57, sine of 57. These y's are going to cancel. These signs are going to cancel. I get y equals 10.8 over sine of 57. And that's equal to 12.88-ish. So h equals 12.88. And then our x we can solve for with the Pythagorean theorem. So we can say 12.88 squared equals 10.8 squared plus x squared. Subtract 10.8 squared. Oops. And I will get that squared minus 10.8 squared is 49.1619, excuse me. That's what x squared is. So x equals the square root of that. So x is 7.01. Last angle is this one, and so I have to do 180 minus 57 minus 90 is 33. So this is a 33-degree angle. Okay. Where I'm going to start with this one is actually finding the hypotenuse. So I'm going to do 13 squared plus 4 squared equals the hypotenuse squared. I'm going to call this c squared. And so 13 squared plus 4 squared is 185. So c equals the square root of 185. C equals square root of 185. All right. So then this angle would be the tangent inverse of 4 over 13, which is 17.10 degrees. And so then 90 minus that is 72.89, or I guess 90, 72.90 degrees. Great. That's the first section of the test. So this has 4 equations, 4 triangles for you to solve. You won't have to solve all 4 on the test. There will be fewer than that, but it's kind of like this. There's a couple of problems like this on the test. I'm just zooming out so you can take a second to pause and take in all this information, and maybe you just need something that you didn't catch while I was talking. So there's all those problems. Okay, the next set of problems is about the unit circle, and so we will be using the unit circle to answer all these questions. The way we convert from degrees into, radians into degrees is we multiply by 180 over pi. And so the pi's will cancel because pi divided by pi is 1. And then 180 divided by 6 I see is 30. So I can see that this would be 7 times 30, which is 210 degrees. Okay. Then we're supposed to do sine, cosine, and tangent. So sine of 7 pi over 6 is the y coordinate at 7 pi over 6. So 7 pi over 6 gives me the coordinate negative root 3 over 2, negative 1/2. And so the sine is the y coordinate. So that would be negative 1/2. The cosine of 7 pi over 6 is the x coordinate there. And so that would be negative root 3 over 2. And the tangent of 7 pi over 6 is equal to the sine over the cosine. And so that would be negative 1/2 over negative root 3 over 2, which can be rewritten as negative 1/2 times negative 2 over root 3. Again, we have that thing where then these 2's are going to cancel. I also see a negative times a negative, and so I know that these are going to turn positive. I end up with 1 over root 3, which again, we have to rationalize. We've done this a couple of times before. So root 3 over root 3, which gives me square root of 3 over 3, and that's my answer for the tangent. Okay, next problem is going the opposite direction. We're supposed to do 300 into radians. And so we just multiply that by the reciprocal of our previous conversion factor, which is this one. And so we will rewrite this as pi over 180. I have to reduce the fraction 300 over 180, which is equal to 5 over 3. And then we put the pi on the top, so 5 pi over 3. The sine of 5 pi over 3, well, 5 pi over 3, by the way, is the angle, is the coordinate negative 1/2. I'm sorry, no, it's positive 1/2 negative root 3 over 2. And again, that's sine is the y and the cosine is the x. So the y is negative root 3 versus 2. So that's the sine, negative root 3 over 2. The cosine of 5 pi over 3 is 1/2. And then the tangent is of 5 pi over 3 is the sine over the cosine. I'm going to put that one over here. I'm going to just kind of zoom in so we have a little more space to do that. So that would be negative root 3 over 2 over 1/2, which is equal to negative root 3 over 2 times 2 over 1. And again, we have that thing where the 2's are going to cancel and we're left with, I'm going to zoom back out so I get a little bigger pen, um, just negative square root of 3. Okay. Next one, it says find the angle psi in both degrees and radians such that sine of psi is root 2 over 2 and cosine is negative root 2 over 2. So on the unit circle, that means that we have a negative x value and a positive y value, which means that this angle is the one we're talking about. This is the coordinate negative root 2 over 2 comma root 2 over 2. And so that means that this is the one we're talking about. This is 3 pi over 4. So we'll write psi equals 3 pi over 4. Or um, what is it? It's 135 degrees. You can just see that on the unit circle too. Okay, this one is a little tricky because it gives us what the tangent is, but what I do know about the unit circle is that when I have a tangent of root 3, I'm talking about one of these sort of steeper angles. And so it could be pi over 3. We could be talking about 2 pi over 3. We could be talking about 4 pi over 3. And we could be talking about 5 pi over 3. And it says, give an angle where the tangent is root 3 and the sine is positive. Okay, so I notice that the tangent is positive here. And so that means that I can't be here and I can't be here because I know the tangents are negative in those two quadrants. The last piece of information is that the sine of the angle is positive, and I know that that means that it can't be this one because the sine is the y values and that one's down there. And so that means that our angle beta is pi over 3. And then we're supposed to give that angle in both radians and degrees. And again, we can multiply by 180 over pi, or you can just look at your unit circle and see that pi over 3 is the same angle as 60 degrees. So again, I'm going to zoom out so you can see all of the problems from that section on this page. I know there's more on the next page, but I just wanted to give you a chance to pause and write down what you need to write down. Okay, the next problem is a little tricky because it's 17 pi over 12. It's not one of the ones that we are going to recognize as a angle on the unit circle, but what I do know is that this is between some of the unit circle angles. And actually, if we kind of think about it, like, isn't this alpha is between, isn't it between 18 pi over 12 and 16 pi over 12? And couldn't I reduce those? And so 16 pi over 12 reduces to 4 pi over 3, and 18 pi over 12 reduces to 3 pi over 2. And so I'm thinking that this angle is halfway between 4 pi over 3 and 3 pi over 2 because I can see clearly that it's halfway between these two angles. All right. And so 17 is halfway between 16 and 18. So if I know that, then I can draw my um, coordinates, coordinate axis. This is where 4 pi over 3 is, and this is where 3 pi over 2 is. And so that means that that angle must be halfway between those two, which means that our standard position angle looks like that. Now, we can't do the sine, cosine, and tangent of this angle directly from the unit circle because it's not a unit circle angle. So we're going to have to use our calculator for this one. Make sure your calculator is in radians this time. And so that's going to give us that sine of alpha is about negative 0.96966, I'll say. The cosine of alpha is equal to negative 0.259, and the tangent of alpha is equal to 3.732. Okay, next one. The angle negative 3 pi over 4. So what I want to remember is that positive 3 pi over 4 is this direction, and a negative angle is the same distance, same angle in the opposite direction. So that means that we're talking about this angle. This is where 3 pi over 4 is, so I'm going to label this epsilon, and then it says find sine of epsilon, cosine of epsilon, and tangent of epsilon. This is actually the same place on the unit circle as 5 pi over 4. So really what I'm doing is I'm asking you about the sine, the cosine, and tangent of 5 pi over 4. So the sine of epsilon is equal to negative root 2 over 2. The cosine of epsilon is equal to negative root 2 over 2. And the tangent of epsilon is equal to 1 because it's sine over cosine, same over same. Okay, identify an angle on the unit circle where tangent is undefined. That means that I have to have a 1 over 0 is undefined, or you could have like a negative 1. So I'm going to write plus or minus here. So theta could be pi over 2, or theta could be 3 pi over 2, because both of those places have a divide by 0 here. And so you can't divide by 0. So if cosine theta is 0, the tangent is undefined. We know that the cosine of pi over 2 and 3 pi over 2 are both 0. So that makes that kind of logical claim. So we say cosine of pi over 2 is 0. Cosine of 3 pi over 2 is 0. And so if the cosine is 0, the sine is 1, the tangent is undefined. If the cosine is 0, the sine is negative 1, the tangent is undefined either way. Okay, then the last one in this section says, are there any angles rho on the unit circle where the sine of rho is over 1? And the answer is no, because here's the thing. Here's the unit circle. I'm just going to draw a little circle here. Look at how good that circle is. Okay, and here's the axes. And so what we know is that this is 1 and this is negative 1 on the unit circle. Well, those are where the sine values are. Sine of rho goes between negative 1 and 1 because that's what the y values are on the unit circle. The unit circle meaning the circle with radius 1. And so, no, there aren't. Okay, perfect. I'm going to zoom out again so you can see all the problems on this section of this page. Pause the video if you need to, catch up to where you are. Okay, this is the next section of the test, and admittedly, this is a little bit hard for me to do on an iPad, and so I apologize preemptively about the shapes of my graphs. They're not going to be perfect, but they're going to be all right. The instructions say to include at least 2 full periods. We're supposed to label the x and y axes carefully. We're supposed to identify some of the things about these graphs and then graph them. So this is a -3 tangent, so the -3 is the vertical scale factor, so that's -3. That means we do have a reflection and we do have a stretch. And then the period is pi over b for tangent, and b is 1/2 in this problem. So that means that our period is pi over 1/2. And I hope we know that that means that we simplify this as pi times 2 over 1 now, which is just 2 pi. Okay, so now that I know the vertical scale factor and the period, I can sketch the graph of the function. This is a upside down tangent function because of the -3. And so I'm going to sketch my best estimate of what that's going to look like. And I do have 3 full periods graphed now because I have those 3 waves. I'm gonna fix this one because it's a little bit wonky and it's gonna make it a little bit harder to do than it has to be. There, that's better. Okay, now the beginning of the next period, the second period is right there. So this is what we're gonna label as 2 pi. This will be 4 pi. This spot right here is halfway between 0 and 2 pi, so this is 1 pi. This must be 3 pi, and this must be 5 pi then. Okay, halfway between here and here is pi over 2. And so now we're going to count by 0 pi over 2, 1 pi over 2, 2 pi over 2, and then 3 pi over 2, and then 4 pi over 2. So this spot right here is 3 pi over 2. This will be 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2. The last spot that I really need you to graph is, or label, is halfway right here. This is going to be pi over 4, which means that the spot that this hits right here is labeled with our vertical scale factor. So this is going to be -3, which makes this 3. And now we have a pretty nice looking graph of a tangent function done. Okay, next problem, 2 sine of 4x. The amplitude is 2. The period is, for sine, it's 2 pi over b. And in this problem, b is 4, so this is 2 pi over 4, which is pi over 2. Okay, we have no upside down. It's not flipped upside down. And so that means that we have to sketch our sine function right side up. That means we're starting at 0. I want you to really carefully watch how I do this because a lot of people are not making this very evenly spaced, which is making it really, really hard to label your axes accurately. So there's one full period. Again, mine is not perfect, but it is pretty close. It's pretty good. And your goal is to make it pretty good. Okay. So now this is 2 full periods because I hit the x-axis here and I hit it here. If that's true, then this is pi over 2. This is pi because it's 2 pi over 2. This spot is halfway, which is pi over 4. And this spot is halfway between there and there, which is pi over 8. Now I'm counting by pi over 8. So this is 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi over 8, and then 8 pi over 8. And then we label our amplitude. This is 2, and this is -2. If you're really fancy, you continue this along to the left as well, and you give this some negative x value. So this would be negative pi over 8. This would be negative pi. Oops, that's wrong. So negative pi over 4. This would be negative pi over 8. There. I guess I'm not fancy.